Everyone, welcome to my channel. I am Ritika and today we are going to solve the LeetCode problem, number of smooth descent periods of a stock. So let's understand what the problem states. You are given an integer array prices representing the daily price history of a stock, where prices I is the stock price on the ith day. A smooth descent period of a stock consists of one or more contiguous days such that the price on each day is lower than the price on the preceding day by exactly one. The first day of the period is exempted from this rule. Return the number of smooth descent periods. Well, in this question, we have to look into 3 points. First is the smooth descent period stock consists of one or more contiguous days. That means one contiguous means consecutive, and one or more. So one means every single element also considered as smooth descent period. Second thing is the price on each day is lower than the price on the preceding day. That means if we consider a day, the price on that day will be lesser than the previous day and the difference will be exactly 1. And we have to return the total number of smooth descent periods. So let's look in the first example. We have 3, 2, 1, 4. Now, if we try to calculate the total number of smooth descent period, first is every single element is considered as smooth descent period. So 3, 2, 1 and 4 itself are smooth descent periods. Then is 3, 2 because 2 is lesser than 3 and they are consecutive as well and their difference is 1. Similarly 2, 1 and 3, 2, 1. So now count 1, 2, 3, 4, 5, 6, 7 and the output is 7. So that is the question steps. Now think about which approach is to our mind whenever we have the word contiguous or consecutive arrays or days or something like that to generate all the subarrays, right? So here also we can think about that to generate all the subarrays and just count those subarrays that satisfy the given condition. But if we do so, the time complexity will be something like n big of n cube. Is it work? No, because the constraint is given as the price length is in between 1 and 10 to the power 5. See, 1 means there will be at least one element in price that denote that the total number of smooth descent periods will be at least 1. Minimum will be 1. And it goes till 10 to the power 5. So n cube will not work. If we try to minimize the time but generate the subarrays, it mostly big of n square, but this is not the optimized solution. So we have to think some solution in big of n. Well, let's try the most optimized approach and see what the intuition is. So we have 3, 2, 1 and 4. Let's write the indexes as well. That is 0, 1, 2 and 3 because we all know that indexes start from 0. Now here we will try to calculate the number of smooth descent period till every index. For every iteration we will calculate that. So for index 0 or till the index 0 we have only one element, one such element or one smooth descent period, that is 3. Similarly till the index 1 we have 3, 3, 2 and also we have 2 itself a smooth descent period. And similarly till index 2 we have 3, 3, 2, 3, 2, 1 and 2 and 1 as well. So for better understanding I am writing here till index 0 here is till index 1 and here is till index 2, but till index 3 we have the same component because 4 will not work because 1 and a 4 is greater than the all the previous element. Can you see here a similar pattern? See, here is, you can see 3 is present for every cases. We have the smooth descent period 3 in till index 0, so that will continue for every cases. Similarly 3 comma 2 and 2 is present in index 1 and that continues in index 2 as well. By using this similar kind of pattern, we can come to our optimized approach. Here we can use two variables. One is count that represent the number of consecutive days up to the current days that from that form the smooth descent period, and initially we will store 1 in count, and another variable is result that represent the total number of smooth descent periods found so far. So now come to the code or program. Let's n is the length of prices array. Now initialize the variable. Why we are storing 1 here? Because we will start iterating from the index 1 and check all the previous indexes. So for I in range of 1, we're starting from 1 until the end and check if uh, prices of says at the index I is equal to the prices of the previous index minus 1 because lesser than the 1, right? And we will increase the count every time it satisfies the condition. Otherwise, the count will reset to 1. And for every iteration, we will add the count to our result. And finally, we will return the result. Now check and run our code. Okay, here now submit. Okay, so our code is working good, and that is the complete solution. Hope you like and enjoyed it, and if you enjoyed the video, please do like, share and subscribe and follow for more such videos.